So I have a square here, and let's say that its height is 1 meter. So this height right over here, that is 1 meter. Now let's say its width is also 1 meter. So I'm talking about the dimensions of the entire square, not just the shaded region. So this is also, that right over there is also 1 meter. So what's the area of the entire square going to be? Not just the shaded region, the entire square. Well, the total area is going to be equal to the height times the width. So 1 meter times 1 meter. 1 times 1 is, of course, 1, and meters times meters. We could write that as a square meter or meters squared, however you want to think about it. Now, with that out of the way, now let's focus on the shaded area. Let's think about what that is. So the shaded area is equal to what? And I encourage you to pause the video and try to figure that out. Well, the one thing that might jump out at you is that our entire area, our entire square is divided into these equal rectangles. So one way to think about it is, well, what is the area of each of these equal rectangles? For example, what is the area of that rectangle right over there? And to figure it out, we could say, well, what fraction is that of the whole? And to figure that out, we have to figure out how many of these rectangles has our whole been divided into. So we could try to count them out, or we could say, let's see, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns, and each column has 1, 2, 3, 4, 5, 6, 7. So we have 10 columns of 7, or we have 70 of these rectangles. That our entire whole is divided into 70 equal sections that we see in these rectangles right over here. So this character right over there, that is 1/70th of the entire area. So 1/70th of 1 square meter, which is, of course, just going to be 1/70th of a square meter. That's just one of these. That's just one of these rectangles. Now, if we cared about the shaded area, we could just count how many of these rectangles there are. And we see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9 columns of 1, 2, 3. So there's 27 of these rectangles, of these equal rectangles in the shaded area. So the shaded area is going to be, we have 27 of these rectangles, and each of them have an area of 1/70th of a square meter. 1/70th of a square meter. And what does that give us? Well, that gives us the area of the shaded area is going to be 27/70ths. 27 times 1/70th is going to be 27/70ths. 27/70ths square meters. And we're done. But what I want to appreciate now is that there's multiple ways that we could have tackled this. Another way we could have tackled it is to figure out what the dimensions are of the shaded area. So for example, what is the height of just the shaded area? So just that height right over there. And I encourage you to pause the video and try to think about what it is. And it's going to be a fraction. Well, we see if we're going in the vertical direction, we've divided this 1 meter, we've divided it into 1, 2, 3, 4, 5. Actually, let me do it a little bit differently. We've divided it into 1, 2, 3, 4, 5, 6, 7 equal sections. That might have been a little bit confusing the way I just drew it. So you can see it when you look at the actually, let me do it in a more vibrant color. So we have, I'm having trouble picking colors. All right, here we go. We have 1, that's that right over there. 2, 3, 4, 5, 6, 7 equal sections that we've divided this 1 meter in. And the height of the shaded area is 3 of them. So this height right over here is 3/7 of the whole, and the whole is a meter. So it's 3/7 of a meter. Now, by that same logic, what is the width going to be? What is the width going to be? Well, we can see that the entire meter has been divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal sections. So going from here to here is going to be 1/10. So this distance right over here is going to be 1/10. Let me do that in a color that's different. So So this distance right over here is going to be a tenth. And so how many tenths represent the width of the green area? Let's see. We have 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths, 9 tenths. So this width is 9 tenths of this whole length, which is a meter. So it's 9 tenths of a meter. And now to find the area, we can multiply the width times the height, or the height times the width. So we could say, so I'll write this again, the shaded area, instead of doing it this way, we could say, all right, I have a height of 3/7 of a meter, so 3/7 meters, and then I can multiply that times our width for just the shaded area, which is 9 tenths of a meter. 9 tenths of a meter. And now what is this going to get us? Well, this is going to be equal to the meters times the meters is going to get square meters, which is what we want. And then we can multiply the numerators and multiply the denominators. 3 times 9 is going to give us 27. And 7 times 10 is going to give us 70. Exactly what we had before. 27/70 square. Let me write that a little bit neater. 27/70 of a square meter. And you can think about why did this work out regardless of how we did it. Notice 3 and 9 in the numerators. That was how many rows and columns we had of these little rectangles. And then the 7 and 10, that's to figure out how many rectangles we actually had. So this is saying, okay, the 3 times 9 is how many rectangles we have. And then the 7 times 10 is what fraction of the whole each of those rectangles represent. And that's essentially what we did up here. So either way, you're going to get the right answer. But I really want you to think about why this was.